All right, time to use those theorems that we've learned about parallelograms and put them to good use. So here we want to find the values of x and y. We're going to assume that for everything on this page, everything is a parallelogram. So it wasn't stated, but it's safe to say that if you see one of these things on this page or on an assignment this week or on a quiz, or it'll be stated, even if it's stated or not, we can assume it's a parallelogram. So go ahead and, unless if we're asking you for it not to be one, or telling you that it's not one. So if it's a parallelogram, we know the opposite sides are congruent. So this is also going to be equal to 9. And then this is also going to be equal to 15. Because opposite sides are congruent. The end. Can you handle that? All right. Now, how about here? Well, this is 51, so the one opposite of it is also going to be 51. But what about these other ones? What about B and D? Well, if we use a property that we know where the where the consecutive angles are supplementary, then we could say, for example, that angle A plus angle B is 180 degrees. But we know that angle A is equal to 51 degrees. So we subtract 51 degrees from both sides, we can get that angle B is 129 degrees. Now if B is 129 degrees, then D is also 129 degrees because it's an opposite angle. So be aware that we use two theorems in this case. We use the theorem that the opposite angles are congruent to each other, and then we use the theorem that said that the consecutive angles are supplementary. The neighboring angles are supplementary. Okay, there's a lot going on here. So let's kind of make a list. Okay, so here's everything. Wow. We are listing here the sides. Here are the angles. And then here's the diagonals, or the little parts of the diagonals. So MN is 8. That means LQ, which is the opposite side, is also 8. QN is 13, which means the opposite side, LM, is also 13. Angles, well, angle L is this entire red arc right here. That's 100 degrees, which means angle N is also 100 degrees. Now, what about angle Q? It is not 29 degrees. 29 degrees is only this angle from here to here. I want the angle from here to here. So we want angle Q. And if we look at the consecutive angles, if that's 100 and L plus Q is 180, well, that means angle Q must be 80 degrees, right? Like we did previously, where we set it up, angle L plus angle Q equals 180. We plugged in 100 degrees for angle L, subtract 100 from both sides, 180 minus 100, 80 degrees. If that's angle Q, then that's also the measurement of angle M, because opposite angles are congruent when it comes to a parallelogram. Now, how about the diagonals? So PN, from here to here, it's 7. That means from L to P is also going to be 7. PM is 8.2, which means PQ is going to be 8.2. Now, furthermore, just for kicks, LN, the entire diagonal LN, is actually going to be 14. So if we want to do some extra, LN is 14, right? Based on the segment addition postulate, because LP plus PN is LN, and that's 7 plus 7 is 14. And furthermore, QM is going to be 8.2 plus 8.2, which is 16.4. Let's do some algebra. Let's find these missing letters, in this case G and H. So, well, we can compare this side to this side. So I can say 16 minus H equals 7, right? We can set opposite sides equal to each other because they're congruent. And if I subtract 16 from both sides, I get negative 9. And I don't want negative h, I want a positive h, so I can divide both sides by negative 1. And I get that h is equal to 9. That's a 9, not a g. That's a 9. Of course, you can always check, right? Plug the 9 back into h. What's 16 minus 9? Well, it better be 7. What about h? I mean, g, I'm sorry. How do you find g? Well, g is an angle, and I have the opposite angle given. We know the opposite angles are congruent to each other. So g plus 4 is equal to 65. If I subtract 4 from both sides, I get that g is equal to 61. Now, we're not saying that this is 61 degrees. We know that this is 65 degrees because it's an opposite angle. What we're saying is the value of g has to be 61 degrees. So if you were to take the 61 and plug it back into here, 61 plus 4 gives us the 65 degrees, which is equal to this 65 degrees. So we're done with that one. This one we have a B, B, and a C, and a D. So we got to find B, C, and D. Well, shucks. Let's find... We could do this a few ways. Let's do this one. These are consecutive angles, so we can set them equal to each other. No, we can't. JK. We set opposite angles equal to each other. Neighboring consecutive angles, we add them up and set them equal to 180 because they're supplementary. So if we go ahead and take care of some business here, well, minus 10 plus 10, that's fascinating. They kind of cancel out. And we have this B plus B. So that's going to be 2B. Right, there's a 1 in front, and there's a 1 in front, if that helps. Divide both sides by 2. B is equal to 90 degrees. Interesting. So obviously this parallelogram wasn't drawn correctly. Or actually, that's a mistake on my part. Snap. Because B is 90, not the angles, right? Because if I were to take this 90 and plug it in here, 90 minus, which we should, we actually really should in this case. What's 90 minus 10? This is 80 degrees. And if I plug in 90 in here, what's 90 plus 10? This is 100 degrees. Okay. So yeah, so the value of B is 90, but these are 80 degrees and 100 degrees. Now doing that is very convenient because then I can use the property or the theorem that says that the opposite angles are congruent. So that means this is going to be 100 degrees, and that means C is going to be 80 degrees. So aren't we glad that we did that problem? Very, very good. You might want to pause and replay that because that was good. That was a good problem. And so just to recap, to make sure that you're clear on what happened, we got the value of B is 90 degrees, and then we got the value of C is 80 degrees. Sorry, I said it again. The value of B is 90, not degrees, just 90. B is 90, okay? C is 80 degrees, and then D is 100 degrees. Good stuff. Okay, this one looks horribly hard. I promise you it's not. This is dealing with diagonals. So we have, let's go ahead and color code this. Let's do, for example, from here to here. That's one that bisected diagonal. And from here to here is the other bisected diagonal. So we know that the bisected diagonals are bisected, which means that they're congruent pieces. So that's 2u plus 2 is equal to 5u minus 10. So we're looking for u and we're looking for v. If we subtract 2u from both sides, and then if we add 10 to both sides, and then if we divide both sides by 3, we get u is equal to 4. And again, it's always a good exercise if you want. I'll mentally do it with you. But if we plug in a 4 into here, 2 times 4 is 8 plus 2 is 10. This is 10 long. If I take the same 4 and plug it in here, that's 5 times 4 is 20. 20 minus 10 is 10. So you see they actually end up being the same lengths. What about v? Well, v is going to be found using the other bisected diagonals. So that's v over 3 is equal to 6. And I know people are scared of fractions. I don't know why. This is division right now. So the opposite division is multiplication. I multiply both sides by 3. I get v is equal to 18. Now, if I were to plug in 18, I could only plug it into this piece right here. 18 divided by 3 is 6. And that's the same as this 6. So we found that v is 18 and we found that u is 4. For your summary in the above problems, sometimes we set things equal to each other. Sometimes we added them up and set them equal to 180 degrees. Point out what happened, when, and why.